The world of dairy is huge, and huger is the complexity of its rheology. But hey, what is this rheology? Rheology is the study of deformation and flow of foods under specific applied forces and correlates closely with food texture. This can be explained by stress-strain curves, which give elastic modulus for solids and viscosity for fluids, and by dynamic modulus for viscoelastic foods. Majority of foods are viscoelastic in nature and therefore complex to describe as just solids or liquid. We care to study rheology because we want to understand the texture of our foods both on the plate and in the palate. The foods deform under gravity as well as under applied force. We exercise all types of forces on foods in daily life. Let's look at the different kinds of forces. This is bending force, the force required to fracture or snap a food. We often fracture food in our mouth. Well, next is shearing. This represents the way in which we cut the food in our mouth or maybe outside. This is multiple puncture for bulk analysis of foods for their firmness. This is compressive force used to measure hardness. Extrusion. This is most pertinent for semi-solid foods. This is penetration test for gels, etc. And this is tension force. Let's now see how we use these in dairy rheology.
Let's enter into the lab and learn closely.
Before start, it's important to calibrate the texture analyzer. It measures force with time. This is back extrusion for firmness of yogurt. The curve shows the force experienced by the probe as it extrudes the sample. This test can be done in the rig used here, or it can be done in the original container of the yogurt to yield similar results. Next, we'll go to cheese. This test is for spreadability of cheese. As the cone contacts the cheese, we see an increasing force with time. There are more tests for hardness of cheese, such as wire cutting test, and the wedge fracture test.
Both of these measure the force required to disintegrate the cheese.
So this product that we see here is ice cream, for which we can use modified texture profile analysis or TPA.
In the original TPA method, the bite-sized food is compressed 2 times to simulate chewing.
Such a test gives hardness, fracturability, cohesiveness, adhesiveness, springiness, etc. Peaks give a measure of hardness and valley of adhesiveness. Next we see here butter whose spreadability can be tested using cones. Higher the peak, more effort it takes to butter your bread. Finally, we test viscosity of milk, which is only liquid in nature.
We do this using Rheosis viscometer.
As we lower the probe in sample, it begins to rotate and measure viscosity, which is obtained from the curve between stress and strain. The slope of this curve gives the viscosity of the sample.
This experiment can be performed holding the temperature constant or by ramping the temperature to see the effect of temperature on viscosity. This table shows the viscosity of 9 different chocolate milk beverages at 5 degrees Celsius. The viscosity of these beverages varies from 6.65 millipascal second to 32.13 millipascal second. So this brings us to the end of this video.
Thank you for watching the video. I hope you liked it.